Kth smallest element in the BST. Given the root of a binary search tree and an integer k, return the kth smallest value, one index, of all the values in the nodes in the tree. Boilerplate code. Oh, whoops. Confirm. There we go. I'm going to pretend the boilerplate code has already been written. I'm going to go through the examples just to speed up this LeetCode process. We have 3, 1, 4, 2. Okay. And we want, so this is the input, we want k is equal to 1. So return the kth smallest value, 1 indexed, of all the values in the node tree. So the kth smallest value would be 1, output of 1. Okay. Any test cases I can think of? Like just off the top of my head. Like empty, right? If root is empty, k, what's like the bounds of k? Well, I guess these are also clarifying questions. Like the bounds of k. Check boundary with length of tree. What if k is in the right subtree? What if in right subtree? Right, so let me just come here. And anything else I can ask before I look at the constraints? Let me do my own example first. So we have a root, well, if it's empty, k, I'm assuming it's only bounded by root, so there's probably an edge case for that. Or probably something noted. If it's not empty, then we'll see what the constraints are there. But let's assume we have this. K, we're gonna imagine that's thick. Jeez. If I zoomed in, oh, I've zoomed in like a lot. Okay, no wonder. Okay, so like that, like this, and then let me just like down here. Okay, and then 1, 2, 3, 4, 5, 6. K is equal to 6. Okay, does that cover like most of the test cases? Yeah, it's gonna be in the right subtree. And yeah. And then I'll choose a different color. So the way I would go about doing this, let me check the constraints. Number of nodes in the tree is n. Okay, it's bounded by n, so it can be 1. And n is bounded by 1 too. It has to have at least 1. Just 1. K is bounded by that. The values in the nodes. Should probably put values in here. 1, 2, 3, 4, 5, 6, 7. Okay. And that means, just thinking about the bounds again, if this is that, this is 1, k can only be 1. Like that's the only option k can be, and so you just return 1. Okay? Now looking at this example, we have to start from the leftmost. So from here, k is equal to 1 at this point. So we move up. The next one in the order, like the purpose of this is find the kth smallest value, right? So we found the first smallest value. Now we gotta find the second smallest value, which is this. I'm doing this wrong, and I am. Hold on. Binary search tree conditions are not met. So let me do that again. So 1, 2, 3, 4. I think we can have duplicates, right? 3, 5, 5, 4, 3, 6. Okay, I think that meets it now. So it's first smallest element, second smallest element. Correct. Second smallest is k. It is 2 equal to 6. No. So we have to keep on going. We check if there's a right subtree because that would be the next element we check. There isn't, so we move up. So we're doing like a left subtree, right subtree. Sorry, left subtree, root, right subtree. 1, 2, 3. We're doing a check like that. Come here over 3. This is 3 now. Still not equal. So we move on to the next one. Now we're at the root. We don't have anywhere up to go. We go down to right. This is 4. Still not equal to each other. We go down into that's not right. That is not right. So as we go down into the right, we have to start from the left point. So now this is 4. Pretty sure that meets the condition. 3 is less than or equal to 3, right? Still not equal to each other, so we move on to the next one. 5. Still not equal to each other, so we move on to the next one. This node right here. Now it's equal to each other. Now we look at what the node is, and this is the thing that we gotta return. Okay, that was a useful example. Ooh, emojis. So now, what's the idea here? I started from all the way in the left, went up to the root, and then the right. If I formulate like a list for myself, that would be helpful. And that's the technique I used before. Can I do this without using a list? Perhaps I can. Come here, then there. Like I have to keep track of what integer I'm at. So I kind of did like here. I was at k is equal to 1. Check. No. Then move up. Do another check. K is equal to 2. Sorry. The counter's at 2 now. Does it equal to k? No. So we move to the next node, appropriate node, in this fashion. Left, root, right. So in that case, if we were doing some kind of recursion, right? We want to do left, like root.left, root, root.right. Right? That's the order we want to do recursion. If there is recursion. And with each step, we check, we have like a counter. Counter 0. And then we want to like wrap this probably in its own like helper. And then keep a track of where the counter is. At any point, if k is equal to counter, then return. Like, then stop. Just return. Wherever you're at. Okay? Now, just to code up. Why is this working? There we go. Just to code up the list solution I have in mind. So delf helper, right? And we want a list of integers. And then we return helper. I guess we want node of some kind. Helper l.left plus root plus helper dot node dot right. And initially the helper will be a root. And then in terms of where you want to like return a certain element from here, right? So you got to return can I do this? I don't know. So k, like if the element at index 0 will actually be k is equal to 1. So you have to actually decrement it like this. Let's see if this works. If it doesn't, then do I need like a helper? Like if, I guess base case, right? Like if node is none, return empty. Okay. Optional tree node. Do I need a self in here? Oh, I didn't read the error message, but helper plus root plus that. Let's see. I was trying to boost my confidence by doing this, but it seems like not valid value for expected return integer. For dot val. There we go. Oh, whoops. I'm like guessing and checking now. This is such bad practice. So now, okay, well, running through the code won't work. So helper root k minus 1, so root, we pass it in. For this example here, we know root is not a problem at all. Like it's not none. So we come to this line over here, root.val. So far we got like a list. It's got 3 in there. And then we run helper. Oh, well, actually, you want to be running root dot helper dot, oh my god, helper node dot left. That's what you want to be running first. But just for easier, just for the ease of visualizing it, I'll write that down, and then helper node dot left. Node dot left is 2. It's not empty, and so to the right, like in the middle, or let me write it down here. In the middle, 2. And then helper node dot left again. This time it's 1. So 1. Doesn't have any children, so it's going to return empty list there. Pop back up to 2. 2 doesn't have, so we have 1, 2. Right? So we have 1, 2. So we actually can write 1 here. 2, and then we gotta do node dot right. We see it's empty actually, so it'll be empty string. And so it'll actually be 1, 2, 3. And then we do, so we've gone back to the root, right? We've completed this at the root level. Root.val, now we gotta do helper node dot right. So we have 5. We gotta run 4. Then gotta run 3. No subchildren for 3. 4. Any right subchildren? No. So this is actually the same. So now we've done left root of this right subtree, and now we gotta look at the left. And we got 6. No left and right subtrees, and that completes our function. And then k is equal to 6, so 5. So 0, 1, 2, 3, 4, 5, right here. That should be giving me the right answer. Maybe I'm messing up the syntax. Let me just look at the solution. What I did to accept this. Order. Def is order. Am I not returning? What is going on? What am I messing up on? Helper root k minus 1. If there is none, return. Root.val, root.left, root.right. Is it because I'm doing node? No, that shouldn't be a problem. Oh, it's because I'm doing root.val. And I should be actually doing node.val. Ah. I see. I didn't want to do like a breadth first search. I'm gonna check the editorial here. Okay, so they also have this solution. Approach to iterative in order. I see. Okay, and then let me come back up here. It's a very straightforward approach. Recursive in order traversal. When an array sorted in ascended order. Is there no way to do it like with like a counter approach? I feel like a neat code also did the solution. All right, I'm gonna leave it at that. This is supposed to be a quick question. So I'll leave it at that. All right.